we move now back to safety. And so we talk about safety of the reactor's systems. I have two distinguished speakers, so I will introduce Mr. Martin Murray to begin with. He has 35 years experience in the UK nuclear industry, and now he works as an environmental regulator. He is a part of the Nuclear New Build Program Executive with the Environment Agency in England, where he works to ensure world-class environmental standards that are applied to design, construction, commissioning, operation, and decommissioning of the new generation of nuclear power plants in the UK. Martin, the floor is yours.
Thank you. Aha, the microphone works. I feel as if I should be dancing. Can I just thank everyone, first of all, for the invitation from this conference. I'm actually here not as a member of the Environment Agency, but a member of something called the Euratom Scientific and Technical Committee. And this is a committee that I would like to describe to you today and give you some more information. And if I can magic the... There we go. So the Euratom Scientific and Technical Committee is an advisory body, but it's a very hidden advisory body within the treaty, which is surprising because it's been around since the beginning. It's actually laid out in the Euratom Treaty, and it asks the committee to give opinions on matters which it thinks is fit, or which the Council of Ministers or the Commission or the officials ask us to look into. And I think that is a very powerful committee, but we tend to give our advice, I'd probably say, in camera rather than in public. So it's the only scientific and technical committee established under the treaty, and it's been active since 1957. So for over 60 years, and I have to say it's not been me that's been here for 60 years, because the committee operates on a 5-year term, and the members are nominated by the Council of Ministers to go on a technical basis to advise in a neutral way based on their technical experience and knowledge on matters which they believe the Commission, the Ministers and the officials should receive advice. So some of that is at the request of Christoph and others who will ask us to look at something, and we will. Some of that is linked to research priorities going forward, but some of it is generated directly by the committee itself. So the committee has a 5-year mandate, and what I want to talk about today in particular, let's go back, is our work in the 2013 to 2018 mandate. And we generate an opinion, and that opinion will be available for you within the papers associated with this conference. Sometimes the messages within that opinion can seem a little bit hidden, but I'll try and draw them out for you today. They're quite direct. One of the concerns of the committee is the need to continually emphasize the need for research and the rationale for that. Now, sometimes it's not always transparent. It was great today to have some ministers from the Romanian government, and both of those individuals had technical degrees and therefore understand science, technology, engineering, and all the things that go with that. However, in some political institutions, sometimes there's a gap between technical knowledge and the people who are driving that at the top. So the committee thinks it's part of its job to give some clear messages at every opportunity around the need to maintain research. So they're up there on the board, and if you can bear with me, I'll go through them individually. First of all, of course, we need to maintain capability. And I'll come back to this because we either need to be intelligent clients for Soviet reactor technology or Chinese reactor technology or American technology, or indeed, in the case of the UK, French technology from the EPR reactor. We won't necessarily be leaders, but we need to decide what we're going to be, in whichever of those two roles, we need to have research so that we've got people coming through the technical schools and the universities who understand the topics, who can then play that role, either as leaders or as an intelligent client, to receive technology and to operate plant to dispose of the waste in the long term. Now, nuclear safety, security crosses boundaries. So you may be in a member state which doesn't or does not want to have a nuclear power program in the future. However, if there is an accident in a member state or an adjoining country, there will be impacts on yourself and ourselves. So therefore, it's important for everyone to realize we need to have that capability independent of how your own member state is going to manage the commitment to be carbon neutral by 2050. And we heard a lot about that this morning. So I'm adjusting my talk as I go along based on everyone else's presentation to try and keep it very relevant but not to duplicate. The need for high standards of safety has already been explained by a number of speakers. The continuous need to improve standards of safety and to ratchet up those. That's embedded within the IAEA standards and the Basic Safety Standards Directive and the Nuclear Safety Directive. We've had a lot today about climate change and the challenge of 2050. At the moment, we've got an established program. We talk about small modular reactor technology, and for those of you who are looking at things like Alfred in the posters, that was saying deployment 2050. Well, if we're serious about low carbon generation, then we're probably talking about deployment of these technologies sooner rather than later. So perhaps there's something, do we have the right ambition for our research and investment over the next 20 or 30 years, or do we need to increase that? Because at the moment, we pay very little across Europe, both within the Commission, through the Euratom program, and also member states. So there's a question there that we need to consider. How serious is Europe about carbon neutral 2050? Do we really understand the implications, not just for nuclear, but for the grid and for a lot of other aspects? Safe decommissioning and disposal of current and future wastes. The committee operates by consensus. So it doesn't operate by majority. So therefore, one area of common ground is going to be decommissioning because all the member states have that requirement. And we need to start to dispose of that waste to ensure that our future generations do not pick that up. And that's a sustainability and intergenerational equity point. And then the last thing I'll touch on is people forget that radioisotopes come from nuclear facilities, either accelerators in some cases, or indeed through research reactors like the Jules Horowitz, should that ever come into fruition. So it's all relative to us, and the research community is central to maintaining a flow of skills and capability to operate and engage with these facilities in the future. And we've already heard the, I think, surprising thing. We need 5 generations of skilled engineers to enable us to dispose of our waste. If you go back, where are we now, 2019? So if you go back to 1898, there was still a battle about canals versus the railways. So where will we be in 100 years' time? And how do we ensure that knowledge management? So, research priorities. None of these will come as a surprise. Fusion. We're still committed to fusion 40 years off. In the UK, I'd probably say still committed to geological disposal 40 years off. How can we close that 40 years so we actually deliver it within the next 15, 20 years and show a real growth. Because if we're talking about carbon 2050, carbon neutral, we can't keep on saying 40 years. Fission. Fission's an interesting one because we always look towards the new shiny toys. And by that I mean fusion, I mean generation 4 reactors. But we've already heard that in order to maintain the contribution from nuclear, even if we don't increase it, we're looking at plant lifetime extension of generation 2 and generation 3 reactors. So fission research had probably got an increased priority if once again we come back to carbon-free 2050. Nuclear materials, as we continue to extend the lifetime of reactor systems, or indeed look to push towards fusion technology or novel SMRs and restart a lot of interest in fast breeder technology, the materials research has to be up there. Because otherwise we will be generating a reactor from which we cannot take out the heat, and we cannot decommission safely, and we haven't thought about the waste implications of the materials before we start operating the systems. But for me, the really important thing about today's research community, the work you're all doing, is those bottom three, which is to maintain the skills, to develop and maintain a future capability, and to enable leadership. The question, of course, is, does Europe lead across all reactor systems and all areas, or do we choose to specialize in some areas? So if you're from France, you may say we will specialize in the fuel cycle because France is good in the fuel cycle, but that might not be the decision across Europe. So, what's the future options? Climate change. It's come along quite rapidly in terms of the politics. I can't say that about the IPCC because I was interested in that 20 odd years ago. But at this moment in time, there's a lot of political interest on climate change and how we can stop not 1.5, not 2, not 3, but possibly a 4-degree rise in temperature. And for people who live in cities, you could be looking at a 6 or 8 degree increase in terms of your temperature within your cities. So this is all the backdrop to research priorities going forward. And we've already heard today that nuclear power appears as part of the roadmap to low carbon generation across the world. And that's mainly Asian in terms of drive. So we have a Soviet commitment to a significant increase in the nuclear generation fleet and sale of that technology. We see the Chinese knocking out reactors at a pace which is barely believable. They can throw up an HPR 1000 in 6 years. And just to give you an idea behind that, some colleagues visited a site and they said it would take them 6 years to throw up an HPR 1000 and explained that this was a part of China which didn't have a large population center. So they decided to build a town 8 kilometers that way through a mountain, but rather than drive a road over it, they've driven through it. So that's centralized economy. And there might be things about the Chinese you may or may not agree with, but that shows the pace and commitment. And then they looked at us, I looked at my colleagues who said, 6.5 years? And they said, no, don't worry, we've already done the first 2 years' work. So from ground to having a reactor operating 4.5 years. So we're not quite there in Europe, but we perhaps need to think slightly faster than we do normally. And the infrastructure, skills, and capability would need to drive that. Small modular reactors I've touched on. If you're going to decarbonize, then you need different heat sources. So there's a role for different types of reactor system. Within Europe, we're looking at a few. Are they the ones that will win? Don't know. But it's very useful that we keep that research open But the question I've got is, are we going too slowly? Fusion, well, I'll just say lots of money goes into fusion. That's a political decision. There's lots of research around it, but there's lots of material science and other areas which stretch across our areas of interest as a research community, as scientists, and there may well be some transition across to some of the other nuclear work that we're doing at the moment. Do we maximise that at the moment? I'm not so sure. So looking forward, socio-economic, and I suppose, Christoph, this is where I have a slight, not disagreement, but I don't distinguish too much between technical research and socio-economic research. I think that if we're going to look at reactor systems, we need to look at it as a whole, because if we don't do the socio-economic bit, we won't be able to do the technical bit because society won't allow us to do it. So I think we definitely need to do a bit more around socio-economics. Safety and operation of nuclear reactors, technology, safety culture, and human factors. And it's the last one of those human factors. If I could see through these blinding lights, I'd ask, are there any human factors experts in this room? Zero. That's a big gap at the moment. We don't have enough human factors experts. We're the problem when it comes to systems. Quite often, ask Boeing at the moment, so it's like divergence there. So we're going to look forward, and as an STC, we're saying we need to do a bit more on socio-economic research. We need to continue to do work on safety and operation of nuclear reactors. If we had another accident in Europe or anywhere else in the world, it would knock this commitment to zero carbon down. We've got the fusion roadmap assessment. We completed one in the last STC, but we recognised, and I think a colleague said from Andra today, that as projects go on, the skill set and the structures and the organisation around delivery have to change and develop. And that's what's happening with fusion at the moment. We're moving to another step as we're looking more towards construction, demo, and various other things. So the STC will be looking at that again in this new 5-year time period, I believe. I've got to say that because the STC still has to get together in about October and decide what its priorities are. And there's a lot of discussion going on at the moment. And then the last one, Joint Research Centre, direct and indirect actions. Well, I'd broaden it out a bit further than that and say member states, because at the end of the day, there is not a vast amount of money within the Euratom budget. Christoph does a great job in grabbing money. We do a great job in getting money within the Euratom budget. But we need to work together in partnership to deliver infrastructure and to deliver a really high-quality research program which will generate the engineers and scientists of the future to support the nuclear industry across Europe. But don't forget, it's not all about nuclear power. And therefore, we're going to be having a focus around non-power generating uses of radioactivity in the coming 5-year term. So we're going to look at medical and industrial, and it's already been mentioned, more around the medical side of things. The last one for me is we can focus very much on Euratom money and Euratom budgets, but there are other areas where we could use research funds. And that's something we need to remember, the broader aspects of other research fields. There's money out there for medicine, but it doesn't bleed across to nuclear terribly well. Equally well, fusion program is doing things. Is there any cross-transference into the fission and other areas? So that was what I was wanting to say to you. It's a bit of a challenge, really, because as a research community, we can roll along with our little bit of funding, we can do some interesting research. Is this the time for a step change? Is this the need and the time linked to zero carbon that Europe needs to move in a different direction? Do we need to have a higher commitment for resources from the Commission? Do we need to have more money from member states? And does it all need to link back to this 2050 zero carbon position? So it's a little bit of a challenge to everyone, I think. But it's the sort of messages that the Scientific and Technical Committee feeds in to the Commission and to the ministers. And we've been seeking to increase the visibility of those messages. And as I said, the STC opinion, which you won't be able to see, but you will have access to a PDF copy on the conference papers, sets out those legacy messages, perhaps in a slightly softer tone, but perhaps not if you knew who was saying it. So that's all I want to say just now. I'm looking at Roger, who was nodding at me. So I think I maybe have said enough for this moment in time. Thank you.
Thank you very much. I think this was indeed quite inspiring.
Some of you have asked, but what is it in this black box?
It's a watch.
So the background is the European flag, and then you have at the top Euradwaste 19 and Uranium 1957. So next time, maybe if you're a speaker, you could receive in 5 years' time another one from somebody else than me, maybe.
So it's my pleasure to introduce the next speaker, who is Roger Garbil, a colleague that I know from many years. He is a physicist, a nuclear physicist, and he has worked in all fields of research and development, fission, fusion, waste management, etc., etc. Roger, up to you.
So I will do like Martin, because it seems that below the light we are getting cooked somehow. So if you agree, maybe I will sit here. I know. Okay, I stand here. All right. So I will try to give you an overview of the R&D we are supporting concerning the safety aspect. There will be some numbers covering also the activities related to waste management or radiation protection. It is more an overview of funding and activities supported and complementing also the STC opinion. Maybe some of you don't see, so okay, let's stay here. I will do the conventional way. All right, so I will mention also a few, some information concerning the next framework program, state of play and the perspectives. First, I would like to say, you see, Europe is very, let's say, diverse, even to say yes or to say okay. We have this challenge. It is not the result of the elections. It is just to say that in Europe we are united in diversity, and I think this is something to be very valued, and sometimes it can be a challenge. But already to say yes, we have this picture which is quite interesting. Today we are in a very important time concerning the decision making related to the multi-financial framework and also concerning the R&D activities, Horizon Europe, which will be the next framework program. On the top you see that everything is related to making an assessment of what has been achieved at European level, at member state level, and all together we try to identify the key priorities that could be supported through the Euratom programs. These were made through a proposal last year in June. They have been discussed today. They are discussed between the European Parliament, the European Council, but also the member states. We had also the intervention from this morning from the Economic and Social Committee. So everybody is trying to give inputs and recommendations for the future. And this will translate in the final decision that will take place in the near future, including the financing, the budgets for the different areas. So this covers everything, all the policy areas, and of course we are more interested to the R&D activities. For the implementation, you know how it works. We have called for proposals. They are based on a 2 years basis. Today we have the last one for Horizon 2020, which is spanning over 2019-2020 financial years. But already today we have to think about the future activities, and even if the call deadline will be in September, we will be drafting already the next one, second half of this year. Of course, in Europe we have elections today, we have also the Brexit, and this is also challenges, and hopefully things will not change so much when it comes to the proposal that have been made, and we'll see what happens. This is a result of, I will not go into details in this, but we speak about trying to be more aligned all together around key priorities, and then this is the overall budget that is proposed. And if you look on the top orange part, research and innovation is within this main chapter. And this is the budget for Horizon Europe, covering the different areas. Open science, global challenges is quite a large share of the budget. Open innovation, strengthening the European research area, it is still to be promoted. And Euratom. Euratom proposal for the 7 years is 2.4 billion. And then on the left, you see the share between fission, fusion, and the GRC activities related to nuclear. ITER is also another decision, and this is another scale of, another order of magnitude. This is the state of play of the proposal, and we will see what happens during the negotiation. I found that this slide is quite interesting to show you, at the end of the day, what happened over the last 2 decades. So Christophe started in FP5. I think I managed to find the figures from FP4. But here you have, on the left, the spanning of the framework programs. They used to be 5 years, and then from FP7, it's 7 years. So for Euratom, it creates always these additional administrative issues because the framework program is limited to 5 years, and it is written within the treaty. So we have to make this additional work in having decision made for the extension of the 2 years. On the second column, in the second column, you see the amount of the total R&D activities. It started at something around 11 billion for FP4. Now we are at 100. So you have a factor of 10 that took place for the overall R&D research at European level. The total Euratom funding you have then, and you can see that overall we are very similar over the last 2 decades. Then you have the fission, fusion, and the GRC. And there again, what can we see over 2 decades? Well, there is a factor of 2 concerning fission. Fusion, pretty similar. For 5 years, you have 750 million euros. For the GRC, well, you have a factor of 2 also. They were 271 today. The proposal is 620. So it's just to show you that at European level, over the last decade, we can see that the proposals have been made in such a way that we keep a share of activities where we really have an EU added value, but at the end, it is maybe not as much as the evolution of the overall R&D activities. And what I want to mention also for the overall R&D activities, lately we have a strong, let's say, commitment towards innovative ways of financing research or different things. So instruments also are coming into the game. And then to the right, I have mentioned also the ITER decision made concerning contribution from Euratom towards ITER construction. Since 2007 till 2020, and then the proposal that is made for 2021, 2027. I think all the numbers are correct. It might be a mistake, so I apologize if there's any, but it should be this. Maybe not all you see it because of this, but The most important part is on the left on this graph. Unfortunately, it's just here. Okay, just to say that the countries that are operating nuclear power plants, of course, they are contributing, are the main contributors to our Euratom project and in a European framework. So it is very valuable to have them. Just to mention that the GRC is identified as an entity because otherwise they get combined with Belgium and it's not necessarily correct. So just a way of presenting this. But also all the other member states, there is clearly here the indication that there is international cooperation. Europe has grown over the last 2 decades, and this is just a summary of the last 2 calls that we have, 2014, 2017. But I think it is a very good illustration of what happens effectively. Effectively, large member countries contribute, but I think they could maybe contribute a lot more. So we come back to discussions of maybe member states could do more in a European framework. And then the smaller countries contribute, but they are usually limited in the funding, in the capabilities, and we have all interest in sharing and working together. I think these are key drivers. The other remark I wanted to make is the way we fund the research is also affecting the total amount of the research projects. And if you look on the top part in the red square, in FP7 we used to limit the big players to 50% of the funding. And this made it as overall for FP7, the Euratom contribution to the R&D activities was equivalent to 57% because the organization were asking usually 50% out of the 100% of the project costs that were identified in the framework of this project. With Horizon 2020 and because also of the financial crisis, the result is that these organizations, including the big players, were allowed to go up to 100%. So in fact, instead of increasing the total volume of the research activities at European level, somehow we have shrunk because the equivalent today is more 92%. So out of the project that we fund, if we have 50 projects, then instead of doubling the amount, we fund almost 92% of these. So this is quite important to mention that the funding rate is also affecting the quantity of work that will take place in a European framework. Overall, I think it was mentioned by Martin, the key areas are there. So geological disposal, reactor systems, existing installations, advanced nuclear systems, PNT and the closure of the fuel cycle, cross-cutting activities, material simulations, etc. Other applications, use of heat, for example, for district heating or other applications related to heat, radiation protection, and then research infrastructures, training and mobility, etc. So these are, I would say, over the last 2 decades, more or less the same key topics. What we have seen also lately is mentioning again of decommissioning. I have indicated here in the top, but it can be in the reactor system. It's just to show on the slide. For radiation protection, we have the indication of non-power applications, but again, Martin mentioned it. Is it to be funded through Euratom? I would say yes, if it is to develop the fuels for the research reactors, for the production of radioisotopes. If it is to train the physicians in the hospital, I'm not sure that Euratom should be funding this. But we are here maybe to cooperate and do more. And then on the left, unfortunately, it's the most important part again. You have the share of the, let's say, the overall budget that took place. Something like 25% again is order of magnitude, because sometimes you can give evaluations much more accurate, but it can be interpreted differently. When we speak about reactor systems, I can assure you that 25% of it is going to existing aging of nuclear power plant, aging of materials, long-term operation. All this is clearly SNETP nuclear activities. Sometimes we hear, but generation 4 shouldn't be mentioned, etc. But if you look at what we do, in fact, it's peanuts. It's very small. And I think it is usually one way of keeping some innovation into the activities that we are promoting. And you know that before getting to a next generation, you need to improve your materials, you need to improve your simulations, you need to do many things which will bring let's say the capabilities you need to have this next generation of reactors. Radiation protection is around 20%, and then 15% concerning the last three topics. And then I would say over the last three, we have something like a share of 5% each. But overall, it's 50 million euros coming from the RTD budget, and the GRC is spending similar amount on a yearly basis by contributing within the RTD calls or in-kind contribution from the GRC activities as such. So overall, it's 100 million euros happening in a European context through the Euratom research project. But we have to know and remain modest on the fact that at the end of the day, we are representing something like 10% of the total public-private R&D taking place in Europe. So Euratom is limited but very efficient, and I can assure you in the context of international cooperation, it is very valuable, and we can see that the community is appreciating this. But today, one key message would be, if something has to happen, if it doesn't happen through Euratom and the budgets that are proposed, maybe member states could do more. Out of this 90% there, 50% is happening in France. So maybe we can send a message to France that maybe you could do more in a European context. It is your interest, but okay. So at the end of the day, this is a picture that can summarize everything. We are working on existing technologies and the evolution of the reactor systems. We try to promote also new initiatives, technology platforms, initiatives related to future systems. But we have also infrastructures. Jules Horowitz was mentioned, but there are also others, like the Alfred here, or that we are promoting one way or the other, or trying to support. Application in the field of radiation protection, reactors for the future for medical radioisotopes, like PARAS. Education and training is important. Fusion is there. ITER is clearly a priority for getting this construction completed and then operation of the ITER reactor. And then on the left, you had also the geological disposal and waste management. You know these figures. I don't invent anything. They are far from the Nuclear Illustrative Program that was published in 2017. The existing fleet is aging. If we don't do any lifetime extension, everything would be shut down by 2040. 20 years extension leads us to maybe 20% still able to run after 60 years. And then if you want to keep the share of electricity as compared to today, in the pink it was close to 20-25%. In the latest 2050 strategy, it is indicated 15%. Whatever the share, it means that new build has to take place. And we are today in 2019, 2050 is not far. And then if we keep the time schedule for building in the Chinese, let's say, framework, it will work. If not, then we have maybe to work out how we will manage. Because at the end of the day, today, this is the graph to the right, the population, the skills, the capabilities that we have, we are more or less following also the gray part. So the trend of this generation from the 60s is following the first thing, the first, let's say, trend. If we don't have a clear impact today in training, having the skills required for building, for operating, and managing all these activities, then we will have clearly a problem. So I invite you to look at the European Research Human Resources Observatory from the GRC, and the key figures are quite interesting. Either we start to train, let's say, large-scale engineers and technicians, and we manage something, otherwise we will have clearly a problem in Europe. And then we are in Europe, but we are in a global context today. Okay, in Western countries, US or Europe, the overall contribution from nuclear is, let's say, more or less stable, but everything is happening outside. Look at Asia, look at India, South America, even our close neighbors are looking for nuclear. We speak about North African countries, they are looking also to build some nuclear. So we have to be aware of this. This is a dense slide, but I just wanted to mention that even though in Europe we have this European context, we try to also remain visible in a European context promoted in the framework of the SET plan. SET plan, at the end of the day, is promoting all the different technologies, solar, wind, etc., but also nuclear. Nuclear is one of the initiatives that is promoted from the beginning. And of course, to keep the picture in this framework is somehow challenging, but I think it's also simulating for the community to be challenged with the other energy colleagues promoting these technologies. And this is the result. At the end, we don't say anything really new. We just say, okay, when it comes to existing technologies, generation 2, 3, Eugenia type, the waste management, etc., we will have to contribute to lifetime extension of the existing fleet. There will be long-term operation activities. And this is to show that it will take place, it takes place already, and this will extend till 2020, 30, 40, even 50. But it remains quite generic, but just to say, there will be new build, and new build is taking place already here in Europe with a few reactors, and there will be more. But we will have also to deal with decommissioning, dismantling. So this is another area that is important. Concerning radiation protection, some let's say, concentration, collaborative work, European joint program is taking place, but it is also rather limited. And we mentioned here the EGP for waste. I think is good news. I don't want to go through all the details. I think a lot of you know it. But clearly there are cross-cutting challenges, looking at all the different areas, one way or the other. And this is how they were presented. At the end, 10 key actions, which are illustrated through all these aspects. I think the bottom one is still important also concerning all the aspects related to security, safeguards, licensing, code and standards. We try to have a more European approach, but we still have a lot to do in these fields. New concept, SMRs, they are there, existing technologies, future technologies, and then also the use of nuclear in a more flexible way. Then this is more related to the advanced nuclear system. So it's a pretty broad, but this is just to illustrate that some initiatives are stimulating the community, R&D, and some results are taking place. If I take, for example, the illustration of the second one, MIRA, today we have clearly an infrastructure that has been promoted in a Euratom framework, identified as an European strategic research infrastructure, S3 roadmap. Today the Belgian government has committed 558 million euros for supporting the construction of MIRA. And this is, I would say, looking at a multi-purpose facility which is covering different fields. So we can only agree in such. The last one here at the bottom is related to other applications of nuclear. Fusion is here, so I just left the animation, but you know it. ITER is the objective today. First plasma, I think it will be 2026. First DT plasma 2035, if I remember. This is the whole animation, but of course there are issues concerning the after ITER already to be promoted. There are different concepts, so the sterilator concept will come into the game at some point. There is a need also to have a facility to irradiate materials and to maybe accelerate the way we want to develop fusion. And then all this needs a lot of work. So I didn't put any timeline, but it's just to tell you there are many challenges. And then finally, these are key enabling conditions. I just go through them very quickly, mentioning it, but without. You need to have the framework for the, let's say, the research infrastructures for the researchers. It can be not only research reactors, but it can be smaller loops for some smaller facilities. And here we had identified also key facilities like the Jules Horowitz and Pallas. These two are the two that were identified within Europe, within a roadmap of European technology platforms, but also in the framework of the set plan. And then these are all the conditions that can help in this. You need to have maybe some other ways of financing research. So here we were mentioning the financing can be maybe made differently. The competencies is a big chapter here, and the last one was related to international cooperation and platforms or European fora that we are involved in. Overall, key achievements, I think many have been launched in FP7 towards 2007, 8, 9. But today we can confirm that one way to go forward in the framework of Euratom is to capitalize what has been achieved and try to do better with the money we have at European level, but surely with the member states getting more involved in what we do. And then also international cooperation with IEA or OECD, NEA are, I think, needed to ensure that we can somehow synchronize some actions related to what we do. Finally, this is something that was published after Fukushima. The European Group of Ethics was asked to do a study concerning the ethical framework for assessing research, production, and use of energy. And these guys were not technical specialists, but we took all the energies on equal footing. And I think this sentence is pretty clear and it's obvious, but it needs to be repeated. We need to achieve the equilibrium between 4 criteria: access rights, security of supply, safety, and sustainability in the framework of social, environmental, and economic concern. So if you get any of these wrong, you don't get anywhere. Electricity too expensive, you get the gilets jaunes, you get many things. So you have to, this is, let's say, a compromise between all the issues that we have, being environmental, economical, or social. And this is true for all the technologies. So we have to work on this, and I think this is a very powerful sentence to summarize everything. I was a bit long, but thank you, Massimo, for your patience.
Thank you very much. I think I give back the chairmanship to Mr. Grama for the panel, because I have to go there.
Yeah. Okay. And in the end of our session, we have the panel general discussion on the role of the Euratom Research and Training Program and the directive challenges and research expectation. In this sense, we expect to have questions regarding all the presentation of today. So, who broke the ice? From the public, from the member states of European Union.
Hello. I have a question.
Yes, please, sir.
My name is David Lowry. I come from the United Kingdom. I have a question to do with a number of matters which were raised by different speakers, so I'll try to make the question clear. Mr. Murray from the Science and Technology Advisory Committee made the point that he thought that the sponsorship of research should encompass a wider perspective than Mr. Christoph Davis had said, and it should encompass socio-economic or social and economic aspects of relevant issues. And in that context, I noticed that when Andrew Orell from IAEA presented his presentation, he produced a very long list of review services that the agency carries out for member states of the IAEA, and the very last one of which was the least used was one called TRANSAS, which he said was on transportation issues. And I want to ask a question on transportation and radioactive waste, because none of the presentations mentioned the transportation dimension to radioactive waste. They all looked at either technology management, looked at development of different aspects of geological disposal facilities, but nobody talked about the transport. And yet, it's almost certain that most of the waste in European countries is not going to be disposed of at where it currently is located. It's going to be treated and moved somewhere else. And therefore, there's going to be a very large movement of nuclear materials within countries and possibly across borders, which gives it a pan-European dimension. So I wanted to ask the question about the importance of Euratom research looking at the implications for the civil society and the general public of a very large increase in the transportation of nuclear materials as these programs are undertaken across the next 40, 50, 60, 70 years.
Who want to respond? Please, Mr. Martin Murray.
Thanks. Yeah, thanks very much, David, for the question. I think there are two aspects, and I don't know if anyone from the IAEA is here, because the focus around transport regulations, as you know, are driven from the IAEA side of things. So I think that's one aspect. The other aspect is, I think there's a general commitment that member states that generate radioactive waste will look after that radioactive waste and will ensure its safe disposal. Historically, we have moved radioactive materials, spent fuel, around the world, and we have returned spent, reprocessed fuel, and we've also returned the equivalent waste. So I don't think this is a new issue, and I think it's taken into account already. Perhaps not quite the answer you were looking for, but that would be my take. If anything, I think for the new generation of reactor systems, the approach that seems to be taken is on-site storage of spent fuel in dry fuel casks, which would tend to limit the transport of radioactive waste through the operational lifetime of the stations, and then the subsequent retention on those sites for a period of time before eventual, at the moment in the UK, disposal in the yet-to-be-developed deep repository. So I guess your question was, does Euratom have a role in this? I think it's a general role in ensuring that the appropriate safety standards are applied, and we've already heard today about the drive to harmonise standards between and across member states. So I don't think it's the answer, but I think it's all the commentary I can give at this time. I don't know if my colleagues wish to speak.
My agency is not directly competent for transportation, but I can only confirm what you said. Of course, transportation is a sensitive question in debates, in public debates, etc. But also, it's completely normal life. At least in countries like France, typically, where there is everyday transportation of spent fuel, of new fuels, and of waste. All around the country, between NPPs, a reprocessing plant, back to the MELOX unit, then back to the NPP. So it's part of the normal life. And in our general agenda, we have no specific needs for additional research on transportation that would be really identified. Saying that, it's a French answer in a French context. Maybe there are some countries where there is not the same organization and where transportation would be something new. I have no example in mind, because in some other country in Europe, even the final disposal is near a nuclear power plant. So, but maybe there are some countries where the question could be open.
If I may add, I think that you need to distinguish indeed two dimensions, one which is the European dimension and one which is the national dimension. So I think that from the point of view of Euratom, both legislation and research, the two things need to be quite separated. The second consideration is that in our legal framework, both the basic safety standards and a specific directive, which is the shipment directive, takes care of all administrative provisions which have to do with radioactive waste and spent fuel movement between member states and between the EU and third countries. So there is a general framework that takes care of that, notwithstanding then the specific safety regulations that indeed derive from the IAEA standards directly. What is true is that when you move to increase the volume of the commissioning, and we have 92 shutdown reactors in the EU that will have to undergo the commissioning, you will see flows towards repositories, whether they are intermediate repositories or whatever they are. If they are centrally located, there can be a substantial increase in the transport flow. Last, I would like to point your attention to the fact that last year we just completed a study on the transport of nuclear and radioactive materials from the Commission, so we can also discuss the result on that.
I would maybe add one point, because I had in mind mainly in your question high-level waste. But if we are talking about the waste coming from decommissioning, the question is not really research on transportation, but from my perspective, the question is research and studies about a global environmental evaluation assessment of the impact of our decommissioning strategy. Because you are talking mainly in this field of decommissioning of waste with a very low radioactivity. So the main impact on the environment is not radioactive one, it's more general one. So you have to take into account the impact on transportation, the impact on landfill, and typically if you are taking waste from a brownfield to put it in a disposal in a greenfield, does it really make sense? And would it not be better not to transport them and to leave them where they are? But it's really a question of methodology, and develop specific methodology of environmental global assessment.
If I could come back on the answers. I think they reflect very much the concern I put into my question, that all the answers that were given were answers in terms of technology and risk, but they weren't in terms of social perception, social concern, public observation, and the importance that that's going to play in the delivery of all these programs. Mr. Murray suggested that it won't make any difference in terms of, because we already move waste, but if you think about moving the entire volume of radioactive waste currently stored at Sellafield to somewhere else within the UK, that's an enormous movement of radioactive materials from one location through the public highways, on the public railways, to somewhere else. If you think of the French situation, at the moment, a lot of materials have been moved from reactor sites to La Hague or to other sites like Cadarache in France, but they will all have to be then moved to the new site where CGO has been placed in the middle of nowhere. A huge number of transportations coming from all directions to one location. That's going to have a massive effect on the public. And if the planners of this program do not take into effect the sociological implications of this huge amount of movements of transports of nuclear materials, then the whole project, however technically competent they are going to run into a massive public opposition, as we saw what happened in Germany. If you remember, 3 decades ago, the German anti-nuclear movement blocked huge numbers of transports of casks from France to Germany. And in the end, the German anti-nuclear movement was so strong that when Fukushima happened, the German Chancellor abandoned nuclear energy in Germany because she knew how strong the German anti-nuclear movement was and would disrupt the policy. So I think that you're not addressing a real issue in the future and not thinking about the importance of looking at sociological, societal, and community concerns about the plans that you're putting forward on a technical level. You're ignoring the societal dimension of the plans.
Thank you, sir. Try to to don't monopolize. And I also have a questions. What is or what should be the added value of the Euratom program, in which domains, decommissioning, waste management, waste disposal strategy, including long-term energy strategy, and how Euratom should provide its support via joint programming or member state program of competitive project proposals?
I think one aspect that we can see, I'm active for many, many years in various projects for the PNT. And I think one aspect that Euratom program have triggered without paying maybe too much attention to the outcome of that is we foster, thanks to the Euratom, it looks to be small money. All time when we speak about program, everyone complains about the amount of money available in Euratom for research. But I would say that nuclear research in Europe is much big thanks to the national programs. And one thing that allows the Euratom program is to foster those national programs in some areas. And if I take the example of PNT effort, we are doing a lot of at national levels in different countries, but this effort of fostering what's going on in the different countries, we succeeded to put this European strategy for PNT with a vision to go to industrialize it at certain moment. With the amounts coming from the different projects, we succeeded in 2005 to put a vision of how can we industrialize the PNT and what are really the building blocks we need for that. And we came as a natural result with all those national programs and the Euratom programs that we put together in 2005. And we continued to foster the calls of the various programs since the FP6, FP7, Horizon 2020, towards this, what are the elements we were missing in order to come to this industrialization vision. Not yet the industrialization, but at least a vision and what are the elements we miss. And we saw that uncertainty, or let's say economic value of industrialization, we were missing by the fact that we were still at lab scale, and we proposed that a semi-industrial scale demonstration for those 4 building blocks, mainly one, the advanced reprocessing that we demonstrated at lab scale. We would like to go for a semi-industrial pilot scale for this advanced reprocessing, advanced separation we are doing through aqueous separation. And I think this is a hint, a drive to the member states, but also to make a global vision towards industrialization. A second block we were pushing, we said we need those advanced fuel containing minor actinide in large quantity. We did demonstrations at lab scale, and we have a good facility in Karlsruhe at ETU, the MALAB, but we need more than that. We need a facility that would be capable to handle up to 100 kilograms of minor actinides, whereas today we do 20 grams. So that's the level of what we need. The third pillar, or the third block, we were aiming to have a transmuter demonstration, and we were aiming to 2 projects, Astrid and Mira, and today Mira get the decision by the Belgian government to make it. So we have there a decision. A fourth block we were willing to get is the pyro reprocessing, because we think if we go to industrial PNT, those heavily loaded fuels with minor actinide that goes in a transmuter, be it a critical reactor or subcritical system, we needed to increase the pyro reprocessing techniques that we are having to shorten the time between 2 passes in the burner, because you have to shorten the time and not wait 10 years before you go a second tour. And that will shorten then the time for the reprocessing and of these heavily loaded. The classical reprocessing remains important and interesting to keep in the game. And so I think this strategy was really a result, from my point of view, that this Euratom program, together with the member state, delivered as a guidance for the future if we want to industrialize. And so I think it has not put clearly in the picture that there are achievements we did, maybe with small money. Yes, we complain all the time about the level of the money for fission program, but it fostered effort of member state, because in the member state, the money which is spent is very important. And we should not underestimate this effort of fostering this member state effort towards clear objective we have together. Because at the end of the day, I think there are problems we can solve together, but the hint of the fostering coming from the Euratom program helps to get there. I think that's one vision I see from my point of view, where Euratom program research on waste management, also fostering the decision for putting those, geological disposal in practice. This is very important also, because even you do PNT, you will not avoid to have a geological disposal, or not geological, because we reduce the radiotoxicity in the time, but we need final disposal system, whatever you do in between. And I think about the question of problem of transports, etc. I think if we do that PNT in a local, one unique place at European level, you avoid the multi-transports then. You do the classical transport that we are mastering today of the used fuel to the reprocessing place. We can send back indeed the vitrified waste, but the dangerous products are treated at the same place in multi-recycling in a very short period and also concentrated way. Therefore, the transmuter you have to look at should be allowing you that.
Thank you, Mr. Hamid. Another question from Pab? Please, sir.
Bill Nuttall from the Open University in the United Kingdom. I'd like to pick up on comments made by Martin Murray and then by Roger Garbil, and to strongly welcome the extension of the scope going forward from electricity into non-electrical applications like medicine and industry. And I'd like to pick up on that a bit. With reference to Gen 4 and possibly even fusion, but let's keep Gen 4 in mind. Thinking back to Apollo, as I recall, President Kennedy famously said, we don't do these things because they are easy, we do them because they are difficult. Yes? And from my perspective now, with hindsight, we've spent the last 20 years thinking that the nuclear renaissance would be something to do with electricity. And I'm increasingly challenging that in my own thinking. Because decarbonizing electricity is frankly rather easy. You can do it with other means than nuclear technology, which is better suited to difficult problems. And meanwhile, the climate scientists are successfully and rightly persuading governments that the real challenge is deep decarbonization. It's going to be to decarbonize the difficult sectors, where frankly I think nuclear is at a competitive advantage. I'm thinking of civil nuclear marine for cargo ships. I'm thinking of process heat applications in cement, possibly even the reduction of iron in smelting with hydrogen. And I'm thinking of making the hydrogen, not from thermochemistry, but from steam methane reforming with an external nuclear heat source and carbon capture and storage. These chemical engineering challenges that are really, really difficult are, I think, helped by a very high temperature reactor. So I think that nuclear power could have a lot to do with delivering the last 20% of decarbonization, not the first 40%. And I think that could really help Gen 4. And I think that could help the STC make the case that it's more than electricity.
Some comments about...
I would like to comment on this one because I found it quite interesting. I think that you are right. In the scenario that we published as European Commission, 2050, nuclear represents, on average, we heard from various speakers, 15% in a world where there is much more electricity, though. So we remain constant. But there is a key question, which is at what speed you are going to deploy what is needed. Take small and modular reactors, which I think they will fit very well what you are talking about. If you imagine to start deploying them in 2035, you have lost the battle. So the key question here is to take existing technologies and make them work in a legislative licensing framework which can deliver or not deliver, because indeed they have to be socially acceptable. So if you miss that element, you will not have them. But this idea of always pushing things, 30 years ahead, I mean, it's very good for research that has to look forward to other things and other applications, but we need to come down and deploy certain things. Now, like, what Hamid was just saying about partitioning and transmutation, we have to move from the laboratory size that we know works to the question as to whether partitioning and transmutation, through a process of innovation, can become an industrial technology which actually is economically viable, because this is the bottom line. Thank you.
Thank you. Other question from public?
No, I was just going to say that the key issue here is we need to agree a roadmap, and then we need to follow the roadmap. Because otherwise we will continue to think about a roadmap and we will not deliver something within the timescales. So I understand your point and your question, but that's where we are today.
I think we have to stop making roadmaps. We have to act. I thank you for the comment. And you know that in the SNETP platform, we dedicated one pillar for the non-electricity use of nuclear energy. And we don't want to make philosophy or roadmaps there. We are looking to projects where the high temperature reactor will be used for either hydrogen production or for the I would say, the fuel for or heat generation also for the purpose of chemical industry. And we are not doing that just in our nuclear island. We love those words in our field, the nuclear island, for talking about the place where you put your reactor. Well, we do that together with chemical industry because they have the problem, they have the issue for having that. We can provide part of the solution, but they are part of the solution. We have to do it in partnership. That's what we are doing in NC2I. And we want really to get it out of the ground as a demonstration project. And I think, indeed, I agree with the comments of Massimo saying, we need to move. We have wasted too much time in trying to solve all the issues in our corner. We have to work together with the users. We have to work together with the ID. We are not making that for the sake of making it. We are making it to create jobs, to create careers for new generation and give them challenges because it will be difficult to do because they need the challenges. They don't need to read the safety reports of the reactors that their grandfather have built.
Please, sir.
Massimo Sepielli from INEA. I have a question to Mr. Massimo Garriba. We participated to JOPRAD project. Many institutions in Italy participated in the 3 years work in JOPRAD to prepare the next joint programming. But finally, we couldn't participate in the joint programming just because we missed the mandate from the Italian ministry. So this was a big problem because we wanted to participate in the joint programming. I mean, INEA and INFN and SOGIN and ISS, so all the main institutions in Italy. And we lost this chance just because the Italian program for the Euradwaste disposal was not ready at the moment, and the ministry answer was that they couldn't sign the mandate just because the program was not ready. So my question is this one. Is the research, maybe the research stopped by some bureaucracy and the ministry, and is not free to participate in the European research programs? This is the question. Thank you.
Please, Mr. Garriba.
Thank you very much. I think this is a question that DG Research should answer better than me, but I don't know the specifics of your situation. But what I can tell you is that well, Italy has a problem with the national program for radioactive waste. There is a infringement proceeding which is ongoing since a while. This is one problem, but the other problem is clearly an internal one, which whereby your ministry prevents you from participating to something which is completely different. So I don't think that this is a European problem. I think this is an Italian problem. So I don't know how to solve it from my side.
It's a question of the mandate. So we are not forced to have a mandate. Maybe we can easily and freely participate in the European program. This is the general aspect of my question.
Well, I need some support here from my colleagues from research because I don't know this aspect. So maybe
this is my field. I mean, Italy and all mandated actors will be able to join later. But you are asking us to accept that you don't have a mandate and you want to be a beneficiary. But this is again against the spirit of integration then. So why should we accept for one country an exception, whereas we impose it to the others? I mean, you're only one country that is not prepared to do it. So please work within your country and then join when you're ready. So, sorry, we cannot adapt the rule to a single country. Otherwise, then it's not unfair to the others, should it?
Okay, thank you. Other questions? We have no more questions. And we declare open we declare closed the session, the panel we have today. Thank you very, very much for the participation of the speakers.